Okay, boys and girls, here goes question 4, 5, 6, 7, and 8 solutions to the Transum trigonometry exam style questions. So I'm going to find BC of question 4, which the angle is cosy between the two sides, so you should know it's the cosine rule, which the standard formula is a squared equals b squared plus c squared minus 2 times b times c times cos of the angle A. Now, fortunately, A is the angle, so we can keep the exact same letters here. We don't need to play about with it. And we just substitute in our numbers. So a squared equals 14 squared plus 17 squared minus 2, and then I'm going to put these in brackets, which represents multiply cos of the angle 118 degrees. So I'm not going to mess about with all the process. You just need to remember that when you enter into the calculator to do the square root at the end. So a is equal to the square root of all this. So what I do in the calculator is do the square root first. You don't have to do that. You could just plug it all in and then do the square root. But I'm going to do the square root, and I'm going to open up brackets so you can see it a bit clearer here. 14 squared plus 17 squared minus, and then I put this one in bracket as well, 2 times 14 times 17 times cos 118. So I opened up 3 brackets there. So taking the square root and processing it all correctly, A is equal to 26.6, and then whatever the units were. Okay, that's a nice easy question 4. Now on to question 5. It says calculate the side BC, which I'm going to label X again. But this question didn't give you the triangle, so the only difference between this one and the first 3 was it just gave you a description and told you that C was a right angle and that BAC had the angle 54 and AB was the size. So you had to draw this using the words. So what have I got? I've got an opposite and I've got a hypotenuse. So you should all know by now, SOHCAHTOA for right angle triangles. I've got an opposite and hypotenuse, so I'm going to use sine. So sine 54 degrees is equal to opposite over hypotenuse. And then if you remember in the first 3 questions, if it's on numerator, then I'm going to multiply. So x is equal to 22.6 times sine 54 degrees. So pop that in, 22.6 multiplied by sine 54, and I get 18.3 to 3 significant figures. That was also 3 significant figures here, and then whatever the units were for the length. Okay, on to question 6. Question 6 was a 2-parter. Question A was nice and easy. It asked me to find NH. I've got an opposite and NH is the adjacent. So the adjacent is X, which is TOA, opposite and adjacent. So tan of the angle 25 is equal to the opposite 390 divided by the adjacent X. Now the unknown is on the bottom, so that means I need to divide. So X is equal to 390 divided by tan 25. So X is equal to 390 divided by tan 25. And that gives me 836.4 units. Now I could just write that as 836 to 3 significant figures, but I'm going to use this in my next part, so I'm going to keep it like that. Now, the next part asks me to find this angle in here, part B. and it also gives me the information that n to t is 230. So I've just calculated what NH is. NH was equal to 836.4, and I know what NT is, which is equal to 230. So to find TH, I'm just going to subtract them. Now I'll just do it on calculator to show you, but you should be able to do that in your head. 606.4 units. So that tells me that this distance here, well obviously this is not to scale. So although it looks smaller, it's actually bigger. Should be a bit more over here. So TH is equal to 606.4. So how am I going to use that? Well, I need to now find this angle in here using SOHCAHTOA. So if I re-sketch that little triangle, that ends up being 390. That's 606.4, and I want to find that angle there. So I've got opposite and I've got adjacent, so it's going to be tan, and I'm going to call this A for angle is equal to opposite over adjacent. Now the reason why I haven't rounded this far is so that I don't get any accuracy errors at the end when I round, but it might not make a difference. So A is equal to, and this time I do inverse tan of 606.4. So you can see that a bit better there. So A is equal to inverse tan bracket 390 divided by 606.4. So that gives me 32.75 degrees. Now that's not me answered the question, because it asked me to find this angle here. Now this is an angle on a straight line, so to find my actual answer, which we can write mathematically NTA, where the angle is at T, NTA, is equal to 180 minus 32.75. So minus 180 for that, and ignore the negative. 147.3 degrees. Now it doesn't actually specify to 3 significant figures, but in IB you do need to get used to 3 significant figures unless stated otherwise. So that would be 147 degrees to 3 significant figures. Okay, so that's me answered question 4, 5 and 6. Now I will answer question 7 and 8. So 8's a little long one. Question 7's pretty straightforward. So question 7 asks us to find the value of x, which is an angle this time, and it just basically tells us that it's an obtuse angle. It's not to scale, and we've got an angle here, an angle here, and 2 sides that we know. Now what I teach the class is that this is opposite to this, and this side is opposite to this angle. So you should spot that opposites relate to the sine rule. And now the sine rule has A over sine A, B over sine B, C over sine C. And now we're wanting to find an angle, so the little trick is not to write this length over angle, but to flip it and write angle over side. So I'm going to write sine A over small a is equal to sine C over C, because I've got sine C, and I've got sine A, and I've got small c, and I've got small a. So that's how I only ever need 2 of the ratios in order to solve the problem. Right, substituting what we know, sine x, because the angle A is x, over side A, which is 32, is equal to sine 33.9 divided by C, which is 20. So then it just comes down to your algebra skills. So this is divide by 32, so when it moves over it becomes multiply. So sine x is equal to 32 multiplied by sine 33.9 over 20. So sine x is equal to, now this is again comes down to degree of accuracy. You could put this into your calculator and then round it and then do it. I try to avoid that, and what I will do is just put it all in as a fraction. 32 times sine 33.9 divided by 20, and then the calculator stores that number. So although I know it's 0.89, I'm going to keep all those numbers in the calculator, and then x is equal to inverse sine of 0.89. So on my calculator I can press that and then do inverse sine, answer. Your calculator stored the previous answer, and it gives me it to a much more accurate number. However, doesn't necessarily mean I'm going to write all those numbers. I will round it to 3 significant figures, which gives me 63.2 degrees. And then I can check how the question gave me the angle. The angle was given to 1 decimal place, so I'm also going to give my final answer to 1 decimal place. So the key in trig is don't round too early, just round at the end. Okay, now we're on to question 8. Question 8 is about a lake, Tamarack. You can check its real location. I'm not actually sure where it is. Now it says Walter takes 10 minutes, 20 seconds to cycle from B to C. At a speed of 29 kilometers per hour. Find the distance BC. Now this is not trigonometry, A and B, so it's not actually test related, so don't worry about these. However, it's a very basic formula that you should have learned in physics and in math, that distance, speed and time are all related. So if I want to find the distance, it's speed times time. If I want to find the speed, it's distance divided by time. If I want to find the time, it's distance divided by speed. But I've got to make sure that my units all match. So this is 29 kilometers per hour, and this is 10 minutes, 20 seconds. So I'm going to change the 10 minutes, 20 seconds into hours. So how do I do that? Well, first of all, I'm going to change it all into seconds. There's various ways to do it, but I'm just going to change 10 minutes times by 60, obviously 600 seconds, plus the 20, so I have 620 seconds. Now how do I change that into minutes? I divide it by 60, so that's how many minutes there are. So you can see that 20 seconds is actually a third of a minute, we already know that. And then how do I change it into hours? I divide it by 60 again. So in hours, it's 0.172 recurring hours. So that's going to help me answer my question now. What is the distance? Distance is equal to speed times time. So the speed was 29 kilometers per hour, that's why I converted it in hours, times by 0.172. So he's not actually going to have travelled much kilometers, obviously. So I'm going to keep the full number in my calculator here, times 29, and that gives me approximately 5 kilometers. So 4.994 kilometers, which if I round to 3 significant figures is 5 kilometers. Okay, distance C to A is 4 kilometers, so this time it's telling us that this is 4 kilometers. I've already worked out BC as 5 kilometers for the purpose of the question. It's rounded, and this time he's running, which takes 25 minutes, calculate his speed. So again, it's not test related, but you should know it. So speed is equal to distance divided by time. Now, his distance this time is 4, but it's in kilometers, and I want to change 25 minutes into hours. So 25 minutes divided by 60 equals that amount of hours, 416 recurring. So speed is equal to 4 divided by that answer, which is 9.6 kilometers per hour. So obviously he runs a lot slower than he cycles. Right, now on to AB. So we know that that's 5, we know that that's 4, we know that that's 22, and it's asked me to find AB, so it's going to be the cosine rule. So I can write it as AB squared is equal to, and then I use the two cozy sides, 4 squared plus 5 squared minus 2 times 4 times 5 times cos 22. And I always like to put that in brackets. And then, as I showed you in the past question, I'm just going to put it all into the calculator under the square root. So it's the square root of 4 squared plus 5 squared minus bracket 2 times 4 times 5 times cos 22. Enter. So my final answer is 1.98 to 3 significant figures. Now, the questions are given as whole numbers here, but I'm not going to round this to 2 because that would be some meters out. It's quite a reasonable amount of error in that, so I'm going to just keep it as 1.98. It doesn't specify in the question actually to what degree of accuracy. So now I've got all 3 sides. That's 1.98 kilometers. It then says calculate the total distance. So again, just do 1.98 plus 4 plus 5. Nice and easy. You can do it without a calculator if you want. So that's the total. Just adding them all together. 1.98 plus 4 plus 5. Now find the angle. Where is it wanting the angle? ABC. So angle at B. So there's 2 methods you could use to find this. You could use the sine rule, because you've got opposites, or you could use the cosine of the angle rule. Now, because I've not done the cosine of the angle rule yet, I'm going to do it here, so you can see. So I know all 3 sides, and I want the angle at B. So looking at the triangle, the one that I subtract is going to be this one. So it's going to be cos B, because that's the angle I want, and then it's going to be 1.98 squared plus 5 squared minus 4 squared all over 2 times 1.98 times 5. So therefore B is equal to inverse cos of all of that. So B is equal to, so inverse cos fraction 1.98 squared plus 5 squared minus 4 squared all over 2 times 1.98 times 5. Close the bracket out, and that gives me 49.3 degrees to 3 significant figures. Okay, now it asks me, last question, what's the area? So I'm just going to draw the triangle quickly at the side so you got all the information. Quick sketch. You got A, B, and C. And all you need for the area is a half AB sine C. So just pop in ones that you need. What do I need? I'm going to just use the reliable ones. 5 is here, 4 is here, and 22 is here. Why would I use an angle here that could possibly be wrong? So I'm going to go for the reliable numbers. So it's a half times 5 times 4 sine 22. These letters just represent the standard form. If I was to write it properly, yeah, it all matches. So A is 5, B is 4, and sine C, so it works. Last part, before I'm finished, is a half times 5 times 4 times sine 22. And that gives me the last part to 3 significant figures, which is kilometers squared to 3 significant figures. Okay, hope all that makes sense. I will put up the answers to 9 onwards over the next couple of days.